On behalf of 24HourAnswers.com, I welcome you to today's lesson. In this video, this is part 6 to integration using substitution, often referred to as U-Substitution. And part 6 here, we're going to do some U-Sub, and we can change our X bounds to U bounds. This will make your definite integration problem quite a bit faster to solve. We're not going to be duplicating our work, and you'll notice that this example here does match some previous videos. Back in part 4 for integration by substitution, we had the exact same problem, and I'm going to take this stuff here and I'm going to use this to help with the rest of the problem. So go back and watch that video there to look at how we completely did the U-substitution where it was required in order to get this antiderivative. And now we have a definite integral. So what I'm going to do here, these are bounds based off of values of x, since we have a dx over here. Now when I come and rewrite this, taking my negative into consideration, and then we have the du. That's replacing the sine x dx as mentioned in previous videos, and then we have 1 over u to the 5th. Again, that was discussed back in part 4. But now, since we have a definite integral, I want to show you a way that we can switch these x bounds to u bounds. All you have to do is take what u is equal to, and let's find our new bounds. How do we do that? I'm just going to draw two little arrows. Cosine of x, I'm going to take this upper bound here, and I'm going to find the cosine of pi over 4. That is our upper bound. Pi over 4, its cosine. The cosine of pi over 4 is the square root of 2 over 2. So this will be our new upper bound when we integrate in terms of u. Let's do the same thing for our lower bound. Let's find the cosine of x. The cosine of 0, well, that's equal to 1. This will be our new lower u bound. So I'm going to slide this over a little bit. I'm going to replace those new pieces with our new lower u bound and our new upper u bound. And now let's integrate this just like we did back in part 4. I rewrote this as the negative antiderivative of u to the negative 5 du, and we are going from 1 to the square root of 2 over 2. Integrating this, we have negative. The antiderivative of u to the negative 5 is u to the negative 4 over negative 4. This is just a recap of what we did back in part 4. And now we can apply these new bounds from 1 to the square root of 2 over 2. And before I apply these bounds, I'm going to rewrite this. We have a negative and a negative here, therefore we have a positive 1/4. I'm going to shoot that u to the negative 4 to the bottom, so we have u to the positive 4, and that piece there should not be new. That's identical to what we did in part 4. Notice in part 4 where we did the indefinite integral, the same problem. Notice we still get this same piece here. Yes, we have a plus c there because this was an indefinite integral. That's exactly what I have here. The new part to this video is us applying these u bounds to this problem. And to do that, let's take 1 over 4. Let's substitute square root of 2 over 2 into u. So I've done that right here. 1 over 4 u, which was square root of 2 over 2 to the 4th power. We subtract, and now we're going to plug the lower bound of 1 into here. So we have 4 times 1 to the 4th power. And from here, this is crazy arithmetic, but this arithmetic here was discussed back in part 5. In part 5, we did the exact same math right here. As you can see, square root of 2 over 2 to the 4th power and 1 to the 4th. However, what we did back in part 5 is we got our U-substitution, then we plug the stuff into x, and yeah, it's extra steps there. In this example here, if you were to work this out from beginning to end, you would do a U-substitution, then you would plug the x stuff back in, then you would apply the x bounds. Whereas in this example, when we do the U-substitution, we get our x bounds and convert them to u bounds, and we don't have to convert back to anything in terms of x. That's the benefit here. And what we ended up getting back in the previous part to this video is we ended up getting 1 minus 1/4. Check out part 5 on how we did all that arithmetic, where 1 over 4 times this stuff to the 4th power gives us 1. And then this is pretty obvious right here. 1 over 4 times 1 to the 4th is that 1/4 for a final answer of 3/4. And there you have it, part number 6. Again, we do the U-substitution, we convert our x bounds to u bounds, and once you integrate this stuff, as long as you have u bounds, there is no need to convert back to the stuff where we had with our x's. This only applies to definite integrals, so keep that in mind. If you were doing an indefinite integral, yes, you would have to do the U-substitution. Then plug the X pieces back in to write your final answer. And that's it for this video. I hope it helped. Be sure to check out our YouTube channel for more videos. Links to our social media are in the description below.